this lecture, I would like to explain about elementary signals or basic signals. In last lecture, I explained about what is signal and what is system. And in signals, we have 9 basic signals or standard signals. And these are the very important signals we remind every time to solve any problem. And these are the 9 basic signals. And first one is unit step signal, unit impulse signal, ramp signal, parabolic signal, signum signal, exponential signal, rectangular signal, and sinusoidal signal. These are the basic 9 signals that we have in signals and systems. These are the 9 basic signals or standard signals. In this lecture, I would like to explain about these 4 signals. Those are unit step signal, unit impulse signal, ramp signal, and parabolic signal. In next lecture, we will see remaining 5 signals. In those, the first one is unit step signal or unit step function. We will also called as unit step function or signal. Here, unit step function, it is denoted by u of t. Unit step signal is always denoted by u of t, letter u of t, and it is defined as, it is the definition of unit step function. Here it is defined as u of t equal to 1 when t greater than or equal to 0 and u of t equal to 0 when t less than 0. Here this is the definition of unit step function. It is the value of u of t is equal to 1 whenever t greater than or equal to, that means t equal to 0, 1, 2, 3 up to so on. Whenever the value is t equal to 0, 1, 2, 3, that means t value greater than or equal to 0, then only the u of t equal to 1. Otherwise, the u of t value is equal to 0 when t less than 0. That means otherwise, whenever t greater than or equal to 0, the u of t value is 1. Otherwise, the value is 0. That means t value should be less than 0. This is the graph of unit step function. And here we have to take, in x-axis we take time and in y-axis we are taking u of t. Here the value of u of t is 1 when t greater than or equal to 0. Here t equal to 1, 2, 3 and up to so on. Here the value of u of t is 1. It is clearly we observe that. And here minus 1, minus 2, minus 3. For these values, the value of u of t is 0. So it is satisfied. When t greater than or equal to 0, the u of t value is 1. When otherwise, the u of t value is 0. This is about unit step signal. U of t is equal to 1 when t greater than or equal to 0 and u of t equal to 0 when t less than 0. This is about unit step function. And another one is, second one is unit impulse signal. Unit impulse signal, it is denoted by del of t. Here unit impulse signal is denoted by letter del of t and it is defined as del of t equal to 1 when t equal to 0 and it is equal to 0 when t is not equal to 0. When t equal to 1, when t equal to 0, whenever in this case only the del of t equal to 1. Otherwise, the del of t equal to 0. T not equal to 0. Whenever t not equal to 0, then the del of t value is 0. Here, this is the graph of impulse signal. In this graph of impulse signal, we clearly observe that when t equal to 0, here t equal to 0. Whenever t equal to 0, then the del of t value is 1. Otherwise, in all cases, the del of t value is 0. So it is satisfied. This condition is satisfied. Here del of t equal to 1 only when t equal to 0. Otherwise, in all cases, del of t equal to 0. Here we have two important points we have to remind every time. Here the integration of, this is the impulse signal. The integration of impulse signal is equal to the step signal. Whenever we apply integration to the impulse signal, then we get step signal. This is the important one. We have to remind integration of impulse is nothing but a step signal. And again in inverse operation, derivation of step signal is equal to the impulse signal. These are also very important formulas. Impulse integration of, whenever we are applying integration to the impulse, we are getting step signal, and whenever we are applying inverse, that means whenever we are applying derivation to the step signal, then we get impulse signal. Integration of impulse is equal to step signal, and derivation of step signal is equal to impulse signal. This is about unit impulse signal. And now the third one is ramp signal. Here ramp signal, it is denoted by R of t, and it is defined as R of t equal to t greater than or equal to 0, otherwise 0, t less than 0. Here this is the definition of ramp signal. It is denoted by letter R of t, and it is defined as R of t equal to t whenever the R of t value is t only when t greater than or equal to 0, otherwise its value is 0, t less than 0. Here we have to see, this is the graph of ramp signal. Here t value is greater than or equal to 0. Here 0, 1, 2. Then only the value should be t, otherwise it is 0, t less than 0. That means minus 1, minus 2. T less than values are 0. Here t greater than or equal to 1, 2 are t greater than or equal to 0. T equal to 1, t equal to 2. T equal to 1 means greater than or equal greater than 0, and 2 means greater than 0. Then the value is t. That means it is proportional to t. R of t is proportional to t. Here whenever the t equal to 1, then R of t equal to 1. Whenever t equal to 2, R of 2 value is 1. T equal to 1, then R of t equal to 1. When t equal to 2, R of t equal to 2. That means linear. It is proportional to time. So that's why t greater than or equal to 0. Whatever the value of t, then R of t is also a same as the t whenever t greater than or equal to 0. Otherwise, it value should be 0. This is about ramp signal. And the final one is parabolic signal. It is defined as x of t equal to t square by 2 whenever t greater than or equal to 0, and 0 when t less than 0. Here the condition is whenever t greater than or equal to 0, then the value of x of t is t square by 2. Otherwise, whenever t value less than 0, the value is 0. Here this is the graph of parabolic signal. Here this is the time and this is x of t. X of t is nothing but a parabolic signal. Here we already discussed about t greater than or equal to 0. That means suppose this is 1 and this is 2 and this is 3. Here whenever t greater than or equal to 0, then the value is t square by 2. Here t square by 2 is nothing but a, whenever t equal to 1, then t square by 2 is nothing but a 1 square by 2 is nothing but a 0.5. In this way, whenever the t value is increases, so the t greater than, for t greater than or equal to 0, the x of t is equal to t square by 2. In this way, we get parabolic signal like this for joining all these points. And another important point in this is integral of how we get parabolic signal is we are getting parabolic signal from step signal. Here whenever we are applying double integration to the u of t, that is nothing but a step signal. Here double integration of step signal is equal to the single integration of, this is nothing but a ramp signal. Here we already learnt about integral of step signal is equal to the ramp signal. Then integral of ramp signal is equal to the R of t is nothing but a, whenever in that case t greater than or equal to 0, then the value is t. So suppose in that condition we can consider in that condition integral of t. dt equal to integral of t is nothing but a t square by 2. In this way we get parabolic signal. Here from step signal, when first of all we are applying double integration to the step signal, we are already know about integration of u step signal is equal to the ramp signal. Then we apply in the place of integral of u of t, we are applying r of t. We already learnt about in ramp signal. The ramp signal is equal to the value is t whenever t greater than or equal to 0. If we consider that t greater than or equal to 0, then here r of in the place of r of t we get t. Here integral of t is nothing but a t square by 2. Then this is for parabolic signal. And another one is u of t equal to d square of x of t by dt square. And if we apply derivation to the parabolic signal 2 times, then we get u of t. And another one is if we apply derivation to the parabolic signal only one time, then we get ramp signal. If we apply derivation to the parabolic signal one time, then we get ramp signal. And if we derivate 2 times, then we get step signal. This is about parabolic signal. In this lecture, I explained about 4 basic signals or elementary signals that we have, and in next lecture, I would like to explain about remaining 4 elementary signals that have in signals. And thank you.